So to start our journey in kinematics, let's define some of our terminologies, right? All these jargons, we need to know what they mean. Now, the first we'll look at the 4 words that in some sense it's similar to the word position, right? If you're a layman, if you've never learned physics before, all these sounds like a similar thing. But let's understand precisely what we mean when we say each thing. And I'll also let you know there's only one of this that we actually use over and over again in physics. The other few, we don't really talk about it that much. So one of them is the most important one. I'll reveal that at the end. You can think about it. You can make a guess right now if you want. Okay, so first of all, let's start with position. So we want to be precise, right? So how do we describe positions properly? Remember when we look at when we first talk about directions, we realize it's not as trivial as you think. And that's why so many people are so bad at giving directions. When you're driving down the road and you're asking for directions and you ask, how do I get to the grocery store? And someone would say, oh, you'll go that way and that, and you go like, what do you mean by that way? There's a certain number of good information you need to provide. It's certain degrees from here, that direction, that way. And now you know which direction you should be heading. Right? Similar with position, right? So I'll give you an example, right? So let's say that's my house, okay? And I want to describe the position of this house, okay? How would you do it? Go like, I'll point at that and say, well, it's there. Well, where do you mean? All right, now you can see me through Zoom and on the whiteboard over here, but imagine this is what you need to do. Imagine you're talking on the phone, right? And telling your friend, you need to describe the direction, the position of this house on this whiteboard. How are you going to do this? Suddenly, it's not so easy, right? Because I cannot just point, it's there because you're on the phone and you're going, well, you know what I mean. No, they don't. And in exam, this is the exact same scenario. You can't draw an arrow. Well, you can, I guess, but that's not the proper way to do. You can't draw an arrow and say, hey, look, there that is. The classic joke of find X and you put an arrow and that's where X is. That's not how you describe things, right? In some sense, taking an exam, it's like talking on the phone. You need to, with your words and equations, you should be able to describe the position unambiguously to the grader. Now, even if you don't care for taking exams, the idea is you are able to communicate through writing. So if I want to describe, if I know exactly how to send a rocket to Mars, then I will write down the theory. Hopefully I pass that to the engineer who's going to build the rocket. They're able to read the instructions and know exactly how to design the rocket so it behaves with the motion that I want it to behave in, right? So that's the goal, all right? So you realize it's not so easy. The first thing you need to do is similar to defining, you need 2 things. Similar to defining or describing directions, you need a coordinate system. Okay, you could have northeast, you could do northeast, southwest, or you could do XY. We'll focus on XY because physics, right? Okay, so 2 things we need. Well, we need a coordinate system. So we need a system, either a coordinate frame of reference. All right, so I'll go like, okay, that's X, that's Y. Does that help? Imagine you describe this. I'm going to define, right? So you're on the phone. You just say, well, the direction that is parallel to the floor, let's call that X. And if you're staring at the board to the right, that's X, you're telling your friend. And going upwards, that's Y, okay? So now where's the house? You still struggle with it because you need a second information. You need a second part. You need an origin, okay? So let's see if that's possible. All right, so now I've defined this way is X and this way is Y. And I've also defined an origin. Notice it could be anywhere, right? So you're on the phone, you tell your friend, okay, you know what? Lay out a piece of paper, draw a horizontal line, draw a vertical line. Where you cross the dots, where the 2 axes cross, that's the origin. Now, you also need a scale. I guess that's 3 things. Sometimes people count that as part of the coordinate system, having the scale. Let's make nice numbers. This. Okay, something like that, right? Okay, so with the scale, now you can start to talk about it. Can you guess what mathematical tool do we use? You guessed it, right? Vectors, right? So because there's how many units of X and how many units of Y, so vectors is a perfect mathematical tool. Now you can tell your friend the complete description. And if the house starts to move, because there's a hurricane or something, if your house starts to move, now you can tell them exactly from where it moves, from which point on the grid to which point in the grid. Okay, so so you need a coordinate system and the origin. In fact, when you describe, notice there is an extra thing of origin, and I guess scale depends on how you count it. You don't need you don't necessarily need the origin to describe directions, right? That's why it was never mentioned in the first couple of classes. To describe an origin, describe directions, you can think about it yourself. You don't really care where the origin is. You just need a reference point, and you're good to go. Right? You can think about it. Is that true? Okay, I'll just move on over here. Right? So, and you guessed correctly. To properly describe this, the correct tool is to use a vector, and this is called a position vector. Okay, and usually the common symbol is R, like this. Okay, it's little r. We don't use P because it's used for different physics quantity. We'll get to it later, but don't ask me why R, but it is what it is. So in my case, this is 1, 2, 3, 4, 1, 2, 3, right? So I can now, right, let's keep it consistent with blue. I can write R of the house, right? So that's the position vector of the house. If I'm lazy, I won't say the word vector, I'll just say the position of the house is X units in the I hat direction and Y units in the J hat direction. In my case, 4 and 3, like that, right? So you can also, so in my case, let me be specific first, 4 and 3. You can also write it as a column, 4, 3. You can write it as a row, 4, 3, like this. Formally, you don't want to put a comma because if you put a comma, it's a coordinate, and a vector usually we don't put commas. Okay. However, once you know that once you know the proper way of writing this, you'll see a lot of professors, a lot of people, a lot of working physicists would, or your TAs even would put a comma there. It's basically like stop signs. Once you learn how to drive, you didn't hear it from me, or blinkers when you switch lanes. But anyway, that's the formal way of doing it. And just to be general, right? So in this specific case, 4 and 3, but just in general, let's put it here. In general, you have xi plus yj, right? You can write it as xy like this. So it's x unit or in a row. You get the idea. Okay, just for completeness, put it here as well. Okay, right. So this is position. All right, good. What is displacement? Displacement is basically the change in position. Okay, we'll define that. Oops. Right. Let's use this little space down here. Okay, the next word is displacement. And the definition is change in position. Okay, that's what this jargon means. That's it. All right. Now, physicists and mathematicians are lazy animals. So the moment we see more than 2 English words, we try to, more than 1 English word, I should say. We try to invent a symbol for it and try to write things. So displacement is usually called S. Okay. Again, D is taken. In fact, it's taken by distance. We'll get to that in a second. And the definition is change in position, right? So it's either R, so it's the final position minus the initial position of the object of interest. Okay, so you might ask, what object? Well, there's only one object. All right, if the house moves, then that is the object. And you might ask, well, what if I have a scenario where there's multiple things moving at the same time? we'll get to that, but you know, one thing at a time, baby steps. We'll start with one object moving. If you want, there's plenty of opportunities down the road. We'll learn about multiple things moving. In fact, the most things that will move at the same time in this course will be 2. So don't worry too much. All right, but we'll start with very, very simple. We'll keep things simple and sort of warm you up very slowly, right? So it's very simple. There's only one object moving. It will move from an initial position to final position. That's called displacement. So as an example, I start from here, and if I move over here, that's my displacement. Okay, now I'll draw it over there. But before I do that, I want to do something even more lazy, is use another very common symbol. You'll see this over and over again in this course and next as well. So throughout the 3ABC series, you'll see this is the word change in. We tend to be lazy as physicists. So we have a symbol, this little triangle, that translates to change in. Okay, so whenever you see it like that, it means the change in position. More formally, change in position vector, but change in position. If I'm being lazy, I'll drop the word vector. So whenever you see change, this literally just means this thing's final minus this thing's initial state. Okay, all right. So let's plot that over here. Right. So imagine this is the house and this is school, right? I don't know why it's a box, but everything's a box in physics, so why not? So this is my initial position. Let's not have the house move. Let me actually move. I'm going from here to here. All right. So I'm going to end up over here. So I'm going to draw another vector. All right. Just to get the scales right. This would be here. Let's say. Let's have 5 units around here. So 4, 5, 6, 7, 8, 9, something like that, right? Okay. And this is the final position. In fact, let me call this house and school. Remember, it's a vector like that. Okay. Now, how do you get change in position or the displacement? All right. Notice it's this subtract by this. In other words, what you can do is you can think of this as minus Ri plus Rf. Sorry about the ink. I'll use a better one in a second. So what that is, do you agree that I can take R sort of positive RF minus RI? I can rewrite that as minus RI plus RF, right? I can put them in different order. So 3 minus 2 is the same thing as -2 plus 3. Think about that, right? So if I interpret it that way, that means I would be going from here minus RI. Remember, that's the initial. Let's put that in here as well. That's the initial, and that's the final in a moment. So minus Ri means I should go backwards, right? So I should go for minus Ri and plus Rf. Okay. So what's the resultant vector? Well, go here plus here, right? You can double check. That means here. And that's exactly what you expect. That is the displacement when you go from here to here. Okay, so double check yourself. S is actually Rf minus Ri. Okay, another way to think about it is take the long vector Rf, right? So Rf would, if you start from over here, Rf itself will take you all the way, somewhere over here, and then minus Ri would take you back to here. So that is this is the triangle way of addition of the arrows, right? It'll take you from here to here. Okay, so that's the difference between displacement and position. Okay, displacement is a change in position. Okay, now what is distance? Distance is basically the magnitude of the displacement. I'll write that down. Yeah, I'll use this space. So if you're wondering what is this little colon and equal sign, I forgot if I mentioned that before. In case you forget, that's the symbol meaning definition. So I'm defining a new word, what I underline in curly line. I'm defining a new word with some old words that you know. So what are the old words? Well, you just learned about what is displacement, and you know what is magnitude, right? So in mathematics sense, so this I'm going to call distance d is defined as the magnitude of s. That's it, right? So you could also equivalently write that as the magnitude of this or the magnitude of this. They're all the same thing because s is this and this is change in distance, means final minus initial. But that is the idea. I'll put it in box, the important ones. Okay, so if I draw one more tick mark over here, 1, 2, 3, 4, like this, right? So it's over here. Okay, so what is the magnitude? So what's the distance from my house to the school? Well, I can check what is the vector of s. Well, s is, let's do it over here. So s is 1, 2, 3, 4, 5. So 5 units to the right and 1 unit to the, going up. So the distance, which is identical to the magnitude of s, is 5 square plus 1 square root. Okay, so that's square root of 26. And if this is a proper homework problem, you want to put that in decimal places, right? In the number of significant figures that is the same as what is given in the question. Okay, so that's the displacement and that's the distance. Now here's the question: is distance and displacement, are they a vector or a scalar? Which one's which? Right. So I think it's obvious. Position is given by a vector, so displacement is also a vector. It's a difference of 2 vectors, but distance is a scalar, right? Distance is the magnitude of it. Okay, so this is basically the 3 key terms. Now, there's annoyingly, there's sometimes motions are not that straightforward, just moving from here to there. Maybe they'll go back and forth, and that makes a slight difference in terms of distance travel. So let me comment on that separately as well.